This paper is starting to be interesting now. So when you go to the next question, it says you're literally dealing with a number pattern. By just looking at this question, I can tell that the first question is about quadratic sequence. That means I need to determine the first and second difference. Or the second question, 2.2, is about arithmetic sequence. Okay, it's only the first difference there. Or they didn't ask about geometric sequence. But if they did, I would know that they will be requiring ratios. So you need to know these things. It boils down to practice, 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 practice. These marks are up for grabs. If you lose marks here, hmm, 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 hmm. Okay, cool. Let's go to 2.1 and solve it. 2.1.1. Given the following quadratic number pairing, which is 5 minus 4 minus 19 minus 40, determine the constant second difference of the sequence. So you literally, let's just dive in deep and not hesitate, because these marks are just up for what? For grabs. They're up for grabs. So the question, let's just say it's 2.1 and 2.1.1. It says 5 and minus 4 and minus 19. Oh, and minus 40 and minus 40. Okay, cool. So you have to determine a difference between this one and this one, this one and this one, and this one, there one. So how to determine difference? You can't say 5 minus 4. You say a term that's like term 2 minus term 1, term 3 minus term 2, term 4 minus term 3. I'm not referring to high school terms. No. Like terms as in like term number. So it's minus 4 minus 5. That's like minus and 9. Minus 9. Minus 19 minus 4, that's minus 15. Minus 40 minus 19, that's minus 40 minus 21. Minus 21, right? So this is, okay. This is your first difference, ne? That's how they write it, first difference, ne? Then now you're determining your second what? Second constant difference. What is your second constant difference? Minus a 15 and minus a 9, and that's your minus a 6. Then your minus or minus a 21 minus a 15, it's a minus 6. So maybe the proper way to write this, or this is your second difference. Say in common difference, like common, common common difference. So maybe for your, I nearly said for your lecturers, but for your teachers maybe to see, you can then say therefore, maybe you say therefore the second common difference is equivalent to minus 6. Then they'll know that you've determined the answer, no? Right? Cool. So we're done with this first part of the question. And the second part, what did it ask us? Let's go back to the question. What did the second part ask us? It asked us to determine the nth term of the pattern. So it's more like determining the formula. So you just have to know these things. Generally, when you're solving these questions or these problems, you mostly deal with the first, I want to say column, but the first, it's more like a column, but it's not a column. You get the point, right? So you'll deal with these first numbers in each and every row. These are the numbers that you deal with. You need to know that the first number, the one at the top, you equate it to what? A plus B plus C. That is what you need to know, ne? And the second number, this one here, you equate it to what? 3A plus B. It doesn't change. It'll always be like this. and then the last number you equate it to what? To 2a. You know what I'm saying? You just have to know these things because they'll never change. They'll always be like this. I'm not saying cram, but know them. Maybe if you're interested, you can go derive and. But then for high school purposes, they don't expect you to do derivation. If you're curious, you can go and derive them from scratch. Right? Like it's easy, but for high school purposes, that's not relevant. It's not examinable. You'll do that when you at varsity maybe, but you'll be dealing with more complex things. But for now, this is what you need to know. Okay, cool. So now, when you're determining the nth term, you need to know that in a quadratic sequence, there was 2.1.2, right? 2.1.2. It's 2.1.2. In a quadratic sequence, your Tn is equal to a n squared plus bn plus c. Ne? Okay, cool. So, you know that your a can be determined using this correlation over here. You see this correlation? You determine your a using that correlation, which says the second difference is equivalent to 2a. I can even say that my a is equal to, minus 3, but let's just solve it for the purposes of, because this is more like a tutorial. So it literally says your 2a is equals minus 6 divided by 2 divided by 2. Therefore, my a is equal to what? Is equal to minus 3. Dango, we have it. We have our a. As simple as that. Okay, cool. Now we're plotting to solve for b. One problem at a time. We determine our b using which correlation? Which correlation are we using to determine b? This correlation over here. 3a plus b equals to the first number in the first difference. So in the second row. So in this row, I'm referring to this row when I say second row. Ne? Okay, so 3a plus b is equal to what? Is equal to minus 9. Okay, let's go down again. So you use that correlation with say 3a plus b is equal to minus 9. But you know your a is minus 3, right? Minus 3 plus b is equals minus 9. Ne? Minus 3 plus b is equals what? Is equals minus 9. I can say from just looking at this thing that my b is 0, but for the purposes of this tutorial, we'll have to work step by step. So this will then become minus 9 plus b equals minus 9. Generally, one would think this will cancel. But now, they don't just cancel. You take this guy over here, you transpose it from the left. You group the like terms in a way. Then your b becomes, what does your b become? It becomes, your b becomes minus 9 plus 9, which is equivalent to 0. Therefore, your b is what? Is 0. Now you have your b. Now the last thing that we need to determine is what? Is c. Which correlation should we use to determine c? This correlation, the first one. This correlation, a plus b plus c is equal to the first term, like in the original sequence. A plus b plus c is equal to what? Is equal to 5 in this instance. So that means you have your a plus b plus c equals what? Equals 5. Okay. What is the value of your a? Your a is 3, your b is what? Is 0 plus what? C equals what? Equals 5. This will literally be your minus 3 plus c equals what? Equals 5. Okay. Then your c then becomes 5. You take this guy over here, literally transpose it. Now it changes the sign as soon as it crosses the equal sign to positive what? 3. And that's equivalent to 8. Therefore, your c is equal to 8. But you haven't solved the actual problem. Let's go back to the problem. What were we asked to determine? You know, when you've been solving mathematics, at times you can even forget why we're doing what you were doing. Go back to the original equation, to the original problem again. It says determine the nth term, Tn of the pattern. Okay, cool. Are we still on the right track? Yes, because we're determining these parameters over here. We were determining these parameters over here. We're determining these values, these guys over here. So we're trying to fill in the Tn equation with the actual values. Okay, we have everything now. We have all that it takes to write the Tn. Therefore, our Tn, you know, our Tn in general, it's an squared plus bn plus c. Therefore, our Tn is equivalent to, what is the value of a? A is minus 3 and n squared plus a 0 ne? Plus a 8. Therefore Tn is equal to minus 3n squared plus a 8. What are you noticing here? This is the answer, but since we are students, we need to notice something. This is linked to functions. It's just that now we're dealing with n's instead of x. So if you were to look at this function, if you were to say this was an x, we're done with the question. I'm just, correlating this section. If they were to ask you to plot this, you know that your function was gonna look downward because you have a negative value of the x squared coefficient, right? So it's gonna look something like this. I wouldn't plot this function, but I'm trying to make you mindful of that fact, because at some point when you approach calculus, they'll ask you to determine the value of n for which the function is at the minimum. What are they saying? Determine a turning point. How do you determine a turning point? You take the first derivative and equate it to 0. But let's just leave it here now. We'll get there. But it's so interesting. When you know mathematics, you touch one thing and you want to bump onto the other one. But let's just focus on one step at a time, because we are students here. We're all learning. Okay, cool. Let's go back to the question paper and see what they asked us in the question paper. Maybe they're gonna ask something interesting. Okay, maybe this question is interesting. They're asking us to determine which term of the pattern will be equal to this. What are they asking? They're asking which n, like in simple terms, which value of n would you plug in the value in the Tn that you determine above, such that the value of Tn is equivalent to minus 25,339. Okay, it's simple. That's 2.1.3 if I'm not mistaken. That's 2.1.3. Okay, it's 2.1.3. 2.1.3. Your Tn is this guy over here, like the one that you determined above here, right? Okay, so your Tn is equal to minus 3n squared plus 8. But your Tn is equated to what? They're saying which term is equivalent to minus 25,939. I think it was 930. Yes, it was 939. Then that is equal to minus 3n squared plus 8, right? Minus 3n squared plus 8. Yeah, so you can just, in simpler terms, you can just group like terms again here, because you don't want to complicate your life, right? You want to use the simplest approach, because the objective is to get 100%. You take 8, you take your 8 to this side, and then at the end you'll be left with 8, man. Okay, we'll change the sign to be a minus. Okay, you can use our calculators to determine that. I think it will be will be minus of 25,947. Right? 947. Let's erase this guy. Let's erase this. Sorry, let's erase this guy. Maybe use a bigger eraser because it's no longer relevant now. Yep. Oh. Okay. 947. 947 equals to 3n squared, ne? Minus 3n squared, ne? Minus 3n squared. Then what you can do at this point, you can just divide by minus 3 so that you leave n alone, ne? Like you leave n in its purest form. So n squared will then be equivalent to, so that means your n squared will then be equivalent to, let me punch in the calculator, it will be 8,649, eh? And at this rate, we should always remember that to get rid of the squared, you introduce a square root. Plus, you don't just introduce a square root, you introduce a plus or minus square root. Yeah? Plus or minus. So that means now your n is equal to a plus or minus square root of this number. So it literally gives you a plus or minus. The square root of this number is 93, no? Is 93. So that means therefore your n should be equal to minus 93, or your n should be equal to what? Your n should be equal to positive what? 93. So it should be equal to 93. Then you ask yourself, what are you dealing with here? Are you dealing with random things, or you're dealing with like term numbers? You'll be like, okay, cool. A term number can never be negative. You can't say this thing is located at negative 94 seats. Like when you count, you always count in positive terms. So this answer is not applicable. You just scratch it. So therefore, your n should be equal to what? It should be equal to 93. Go back to the question and check if you've answered the question. What were they asking you in the original question? They asked you to determine which term in the person will be equal to this. You haven't really answered the question. You just determined the value of n, right? You just determined the value of n. Then you'd say, if you want to answer the question now, therefore, the 93rd term will be equal to minus 25,939. You know what I'm saying? So it's simple as that. You just solve it simple as that. You're done with this question. You're just done with this question. Okay, before we run out of time, let's go to the second part of the question. We were talking about the arithmetic sequence. There was your 2.2, if I'm not mistaken. It was 2.2, ne? Okay. Let's go to the question paper. It was saying the first three terms of arithmetic sequence are this and that. Okay, before, let's just copy this to a next page, I guess. Let's just copy it into a next page and open a new page. Open a new page. Then paste this. So we have sufficient space. Or maybe let's insert it, because we do have this in our curves. Okay. Okay. We're solving we're solving 2 point what? 2.2, right? We're solving 2.2. We're saying the first three terms of the arithmetic sequence are 2k minus 7, k plus 8, and 2k minus 3. So the only thing that you need to master here is that the first difference is the common difference. So if you've mastered that, then you're cool, right? Okay, cool. Let's just solve the question. It's 2.2 and 2.2.1. Maybe let's zoom out a bit. Oh my gosh, we just lost our thing. If we zoom out, where is our page? It's here. Zoom out again. Let's delete this guy over here. Okay. Let's zoom in again. Zoom to 100, and then we solve our problem at hand. It's 2.2.1. It says calculate the value of the 15th term of the sequence. So the first term was 2k minus 7, and the second term was k plus 8, and the third term was 2k minus 1, 2k minus 1. Okay, cool. Let's just determine the first difference. You just determine the first what? The first difference. And the first difference in this case will be k plus 8 minus open bracket 2k minus 7. That's the first difference in this side. And here it will be 2k minus 1 minus k plus 8. You get what I'm saying? So it will be like that. But what you need to note is that these are equal because it's the arithmetic sequence, right? These are equal. They're literally equal. So let's just solve for k in this instance. No? Let's just solve for k. Why are we solving for k? Because we want to substitute back the value of k such that we only have numbers here instead of us having alphabets. No? Okay. Let's solve for k then. Let's drop this here. K plus 8 minus 2k plus 7 equals 2k minus 1 minus k minus 8. Né? Then it will be literally k minus, or 2k minus will be minus k this side. 7 plus 8, that's plus 15, because 8 plus 8 is 16 minus 1, that's 15. Equals to, oh sorry, it shouldn't be 2k. Also k here, né? It should be k minus 9. Né? Let's group the like terms. I'll just take this side and take this side. Right? Yeah, so it's easier for me to, I don't want to have a negative, so I want to convert all my unknowns into positive things so that I don't have to divide at the end. You know what I'm saying? So let's go down here. It's literally then boils down to become 15 plus 9 equals k plus k. Then 15 plus 9 is, what is 15 plus 9? I think that's 15. 9 can be broken into 5 plus 4. That's 24. Ne? 24 equals 2k. Then you divide by your 2, These guys sorry, they don't cancel here. They cancel here, and here you left with 12, no? You left with what? With 12. Therefore, your k is equivalent to 12. Are you done solving the problem? No, you're not. Go back to the original thingy. What did it say? You wanted, the main reason you determined k is because you wanted to eliminate these guys, like eliminate them and plug in, and just plug in and only have numbers there. So if you then go down, your value of k is 12. So wherever there is k, you plug in 12. So then the first term, I'll just plug in the calculator now. So the first term then becomes, if you say 2k minus 7, then k is 12, then it'll become 17. And then the second term will become 20. Will become 20. And then the third term will become 23, no? And then they proceed, right? They go on and on and on. So if you determine the first difference here, you see that the common difference is 3 here, right? 23 minus 20 is 3, 17, 20 minus 17 is 3, no? For simplicity, generally, as you're a metric student or metric students, they're given a formula sheet. So if you've forgotten some formulas, you go to this thing. You see here, you're given the formula for an arithmetic sequence, right? It's just given to you. Tn equals this. And for a quadratic, you need to know it by head. But for arithmetic, it's given, hey? It's literally given. Yeah, it is. Okay, cool. Then you go back to your original problem, to where you're solving your problem. You literally say my Tn is equal to a plus into n minus 1 and d. What's your value of a? Your value is the first, your a is the what? Is the first term of the sequence. So it's literally this guy over here, ne? So this is your a, ne? And your d is what? The common difference. This is your d, ne? And then from there you literally plug in the values of a and d. So it's Tn equals 3 plus n minus 1 into d. Your d is 3. Sorry, your a is not 3. Just made a mistake, eh? Okay, your a is what? Your a is 17. So your a is 17. If you rearrange this thing nicely, you literally get your Tn. Your Tn will become, it's gonna be literally you eliminating this bracket. There will be 3n, 17 minus 3. That's like what is it? 12, isn't it? So it's literally gonna be, why am I saying 12? I think it's 14, yeah. So it should literally be 3n plus 14. Yeah, it's 14 because 3 plus 4 is 7, so 14. And now what was the question saying? Because it's easy to lose track of the question when you've solved a lot of like when you've determined a lot of factors. Let's go back to the question again. What was it saying? What are we calculating so that we don't lose ourselves? They're saying calculate the 15th term. So now they're saying plug in the value of n such that it becomes 50. Like plug in, they just gave you the value of n. You have the value of n here. Your n is what? 15. Therefore T15 is equal to 3 into 15 plus 14. And then that boils down to what? It boils down to, let's plug in 3 times 15, 3 times 15 plus 14. That's your, I'm getting a 59. So that means my T15, therefore my T15 is equal to what? 59, eh? Okay, cool. we're done with this problem. We just solved 2.2.1. Now we need to go to 2.2.2. That will be our last problem of the day. 2.2.2. That will be our last problem of the day. 2.2.2. Calculate the sum of the first 30 even terms of the sequence. What are even terms? What are even numbers? What are even numbers? Those 2, 4, 6, something. 2, 4, 6, 8, 10. Yeah. They can be divided by 2. That's how I understood them in my early grades. Ne? Yeah, so let's paste this here so we don't have to go up and up and up. So they're saying, what's the question again? They're saying, calculate the sum of the first 30 even terms of the sequence. The sum of the first 30 even numbers of the sequence. Okay, cool. So it's literally, we have in the sequence, we have 17, we have 20. That's 2.2.2 now. We're solving 2.2.2. This is what we're solving. Eh? We have 20, we have 23. You can also have 26. I mean, because you're just adding 3s, you can have 29. You can also have what? 32. You can also have 35, etc., etc., etc. I mean, it goes on and on and on and on and on and on. But see, the storm keeps rolling and rolling until infinity. Ne? Okay, cool. So now they're saying we should only focus on the even terms. What's the first even term here? This is our first even term. It's 26, 9. So these are 3 terms. We only need 3 terms if you're dealing with the arithmetic sequence. So that means now our new sequence becomes 20, 26, and 32, right? 20, 26, and 32, and so on. This is one for what? For even terms, ne? This is for even terms. What's the difference for these ones? What's the difference for what's the first difference for these ones? You can just simply say, what's the difference here? What's the difference here? It will literally be 6, right? So that's the difference. So you know that your D is equal to 6 and your A here is equal to 20. What is the question saying? Before we lose our train of thoughts again, let's go back to the question. What are we calculating? It says calculate the sum of the first 30 even terms of the sequence. So we're even giving an n here. We're also giving an n. Your n is equal to 30. They're saying we're calculating a sum. A sum. Let's go back. Let's go to our formula sheet. You see this formula here. It's literally sum at a specific n. So we just need to copy that formula here, right? Take it to our problem. So the formula says Sn is equal to n over 2 into I think it was into 2a, if I'm not mistaken, 2a plus into n minus 1d. Yeah, that's the right one. So you know that your n is equal to what? 30 equals 30 over 2 to 2. What's your a? What's your a is 20, right? Your a is 20. Let's go back and confirm. Yes, your a is 20. When you look at it here, it is 20. It is 20 here. It is 20. Your a is 20. Let's go down and solve our problem, okay? Then you write 20 plus your n is 30 minus 1. What's your d? It's 6, ne? Your d is what? Your d is 6. Therefore, your S30 is equal to, you just have to plug this in your calculator. I mean, you don't have to complicate your life. Is equal to 3,000 to what? Okay, 3,210. That that is what I'm getting, ne? That is what I'm getting. I'm getting 3,210. But the logic is simpler. Follow the questions, solve it. When you've solved for many variables, go back to the question. Am I still in line with the question? Yes, no. What am I missing? Nothing. Let me proceed. Am I still in line with the question? You proceed just like that, just like that, just like that. Yeah, we'll touch on the next question in the next video, in the next lecture. If we look at it, let's just take a glimpse and see how does it look like, so we know what to look for in the next question. Because we've done, I'm worried that we won't have a question that touches on what is it called, on the geometric. Oh, here's the geometric one. That's fine. Question 3 is the geometric one. Before we head on to my favorite chapter, which is functions. So let's just pause this video here. We'll touch on geometric sequence briefly.